In the U.S., most power is generated at centralized power plants. Might be a hydroelectric dam like at Bonneville, might be a big wind farm like out in eastern Oregon. Some sort of centralized system, and the power is sent over these transmission lines to substations, which are like giant switches with transformers. And from the substations, that power is then distributed out to businesses and houses. We talked about alternating current a little bit last time when we looked at sine waves. The reason we are all using alternating current is because when we distribute power over very long transmission lines, there's voltage drop. And the longer the distance, the greater the voltage drop. The thing about alternating current is that you can use a transformer with that stuff. And so what they do is at the power plant, Bonneville Dam or wherever it is, they take that current and voltage coming out of the power plant and they use a transformer to boost it, to step it up a lot. And then they push it over these transmission lines. And yes, there's some voltage drop, but there's so darn much voltage, 230,000 volts, 500,000 volts. There's so much voltage that even with the voltage drop, you still have plenty by the time you get back down to your substation. And then you get to your substation and you step that voltage back down with transformers and you send it out to the customers. DC current, direct current, you cannot do that with. You cannot use a transformer with DC, so that's why we're on AC. Now all this goes out over what we call a grid. And the grid is this vast network of interconnected lines. And this has two main functions. First of all, we have some unmovable power sources, like Bonneville Dam on the Columbia River, like a giant wind farm in eastern Oregon. We can't move those, so these lines on the grid get power from there down to where people need them. The other thing the grid does is it provides, it balances the load. So if you get too much demand in one place and not enough demand in the other place, the grid will kind of spread that all out, even it all out, so everybody gets exactly how much power they need without overloading and without the lights dimming. There are 3 subdivisions in North America. We are in the Western interconnection, and you notice that includes the US and Canada. There is an Eastern interconnection, and then Texas is so big that it has its own grid. So there are 3 basic interconnection grids in North America. And within each interconnection, for example, we are in the Western section, so within our Western section, all our generators are synchronized. So it's easy to send power over these lines and have the load balanced, and whoever needs power can just get it without those waves being out of whack. Then there are connections between the Western and the Eastern, looser connections, and they have high-tech equipment there, but those 2 sections are not synchronized. So we are going to look at 2 different ways to make and distribute power. Centralized power means the power comes in from the utilities side of the power meter, and it could come from a wind farm, it could come from a hydroelectric dam, but it's some big installation that's kind of centralized, and the power gets sent out from there to the substation and to you. That's centralized power. Distributed power is power that's produced on the customer's side of the meter. So for example, in LCC's parking lot, here is this array of solar panels. We produce electricity with these panels on our side of the meter. And if we produce more than we need, we can send that power back through our meter to the grid and sell it back to the utility. And that ability to, meters can record power flow both ways. And that ability to send the power back the opposite direction and get credit for it is called net metering. You probably have heard that term if you've heard people talk about connecting solar panels to their house and they want net metering. And you might say, well, is that even legal? Yes, it is. In the U.S., there are federal laws that mandate net metering. And there are federal laws that say you are allowed to produce power if you're an independent producer. And the idea is, if you produce power and you send it out over transmission lines, and then your neighbor produces power and they send it out over their transmission lines, and everybody has a set of transmission lines and substations, that's just fabulously expensive. Nobody could afford to do it. So the law says we are required to have utilities that can manage all this flow, and there are laws that prevent them from forming monopolies, including laws that mandate net metering. I know sometimes it gets a little bit squishy, but net metering is the law, and here are the U.S. laws that mandate that. So now we're going to go look at grids, specifically in a distributed way in microgrids.